Let's find the derivative of the given function. In this case, it's an integral from x squared to x7 of 2t minus 1 cube. And this is the hardest example in this chapter. Let's go over it together. We know how to deal with cases when we just have it from a to x. You just substitute in, and you are happy about that. From a to x to the 7, you substitute in x to the 7 and multiply it by derivative of x to the 7, which is 7x to the 6. That's chain rule. We even know what to do if it is from x squared to a. Then you just flip it, right? And then use chain rule. But in this case, we need to combine all the knowledge we learned, which is basically a classic idea in math classes. Let's combine the knowledge. I would like to break this integral into two integrals. One will be from x squared to a, 2t minus 1 cubed dt. And another one will be, what do you think? How do we combine? How do we break integral into two integrals? Correct. It will be from a to x to the 7, 2t minus 1 cubed dt. This comes from the idea of continuous functions, and the area is also continuous if the function is continuous, and we know that the function is continuous based on the fundamental theorem of calculus. We have it something like this, from one point to another point, and we find a breaking point somewhere here, and now we work with one integral first and then another integral after that, like that. Sometimes we even like to call it I1 and I2, integral 1 and integral 2. You will see in your homework and classes that we often use 0 as a breaking point. Does any constant works? Well, it has to be in the middle, it has to be in between. And also sometimes the vertical asymptotes are involved, and that should be kind of a question of a smart choice of that breaking point A. But in this homework, you will not have any complications with the choice. So let's proceed. This will require two steps. Let's find a derivative of, with respect to x, of integral 1. And then let's find the derivative of the integral 2. So I'm differentiating an integral from x squared to a, 2t minus 1 cubed dt. This is the case when I need to flip the integral, so I will be differentiating the integral. And by flipping, I mean I will write down it as the integral from a to x squared. How to do that? You have to put negative sign in front of it, based on the properties of integration. 2t minus 1 cubed. Now you can substitute the variable. When you differentiate the integral, differentiation undoes integration. So you just have the function inside. Oh, I missed the dt part, right? Let me put dt over here. The function inside is 2t minus 1 cube, but also negative in front. Let's not forget that, negative in front. But instead of t, now I will have x squared. So let me substitute x squared instead of t. Then I notice that x squared is a function inside of the 2t squared minus 1 cube function. So by the chain rule, since we're differentiating, we need to deal with chain rule. We need to differentiate x squared. So we have 2x at the end. This step required chain rule. So I would say plug in, and chain rule. That's what I did in the very last step. And this is the answer for the first integral. Step 2, as you can see, it actually goes fast if you know what to do. Let's differentiate the second integral, which means it will be derivative with respect to x of the new different integral. It is from a to what? X to the 7 this time. Can you finish before me? I wonder if you can be faster than what I do. Try. 2t minus 1 cubed dt. No need to flip here, so I can skip that step. Thus, it will be 2. Instead of t, we will have x to the 7. Maybe put in parentheses. Sometimes that helps if there is some calculations need to be done. Minus 1 cubed. And then I thought it should be done, but I remembered that, oh, I also need to differentiate the function inside. The function inside is x to the 7, so it's going to be 7x to the 6 over here. And that is the answer for the, let me put it in red, the answer of the second integral. The final answer is what? Combination of those two answers. And by combination, I mean a sum, because that's what we had over here. Well, the answer is negative 2x squared minus 1 parentheses cube times 2x plus 2. Oh, my parentheses are wrong over here. Yep. Did you catch this mistake? You see, I wanted to be faster than you and mess up. Parentheses should be outside. Parentheses are important. 2x to the 7 minus 1 cubed times 7x to the 6, where the last parts, 2x and 7x to the 6, were corresponding derivatives of the functions x squared and x to the 7. Hopefully that was not too fast. Maybe pause a couple times and work through this problem by yourself. Thank you for watching.